What if I told you that right now, 124 light years away, there might be microscopic life forms producing gases in the oceans of an alien world? What if I told you that scientists just found something strange on another planet that is changing how we think about extreme worlds in space? Stay with me, as the revelations from the James Webb Space Telescope will astound you, but first we must address a significant issue. Let me illustrate the K218 star system for you. Imagine a red dwarf star, smaller and cooler than our Sun, with two planets orbiting it. The first planet, K218c, hugs so close to its star that it's basically a cosmic furnace, completely unsuitable for any form of life as we know it. But the second planet, K218b, has become the center of one of the most exciting and controversial discoveries in modern astronomy. The James Webb Space Telescope discovered something truly extraordinary in the planet's atmosphere when it directed its incredible instruments toward K218b. The telescope detected methane, which might not sound exciting to you, but here's why astronomers are losing their minds over this discovery. Methane typically gets destroyed by stellar radiation within just 2 to 3 years, so if there's methane present in our atmosphere, something has to be actively replenishing it. But that's not all. The telescope also found an abundance of carbon dioxide and a notable absence of carbon monoxide. These characteristics are remarkably similar to what we see in Earth's atmosphere. However, the discovery that has scientists both thrilled and terrified is the potential detection of something called dimethyl sulfide, or DMS for short. Now, here's where things get really interesting. On Earth, DMS is only produced by certain types of algae living in our oceans. It's essentially a biological signature that screams, life is here. If this detection is confirmed, we're not just talking about finding evidence of life on another planet. We're talking about potentially detecting the actual byproducts of living organisms floating around in an alien atmosphere 124 light years away. The planet itself is fascinating from a physical standpoint. Based on density measurements from the Webb telescope, scientists believe K218b might be what we call a Hycean planet, essentially a water world with an enormous ocean covered by a thick hydrogen atmosphere. The planet likely falls somewhere between what we'd classify as a super-Earth and a sub-Neptune, making it roughly 8 times more massive than our home planet. Picture this world in your mind. The hydrogen atmosphere would create a greenhouse effect, keeping the vast ocean slightly warmer than Earth's seas. The atmospheric pressure would be intense, and the entire planet might be one massive, deep ocean with no land masses whatsoever. In such an environment, if life existed, it would be completely aquatic, probably microscopic organisms floating in the alien seas, producing methane and other gases as they go about their mysterious biological processes. But here's where that problem I mentioned earlier comes into play. Researchers from NASA's Ames Research Center and the University of Washington decided to test these exciting interpretations. They developed 2 entirely different models to explain what Webb was observing. The first model describes exactly what we've been hoping for: a rocky planet with surface oceans teeming with microbial life. Simple methane-producing organisms, similar to certain bacteria on Earth, could be continuously replenishing the methane in the atmosphere while producing the other gases Webb detected. However, the second model presents an entirely different perspective. This model suggests that K218b might actually be an uninhabitable gas-rich world without any solid surface at all. The model suggests that K218b lacks oceans and life, with a thick, poisonous atmosphere of gases swirling around a planetary core that we could never reach. Here's the shocking part. Both models fit the Webb telescope's observations equally well. The uninhabitable gas planet explanation might actually present fewer scientific challenges than the exciting life-bearing water world scenario. The ocean world model faces a significant problem called the runaway greenhouse effect. The same thick hydrogen atmosphere that could keep the oceans liquid might also trap so much heat that the planet becomes far too hot for any form of life to survive. We're talking about temperatures that could boil away any water, leaving behind a hellish world where the very chemistry we're interpreting as signs of life is actually just the result of extreme heat and pressure. Scientists are now suggesting that before we get too excited about finding life on exoplanets, we need to first determine whether these worlds are even cool enough to maintain liquid water oceans. It serves as a stark reminder of the challenges in comprehending worlds located trillions of miles away. The upcoming observations from the James Webb Telescope could definitively resolve this debate. If the telescope detects ammonia in K218b's atmosphere, it would strongly support the uninhabitable gas planet model. But if it confirms the presence of DMS, we might actually be looking at our first definitive proof of life beyond Earth. While we're waiting for those crucial observations, let me tell you about another world that's equally mind-blowing, but in an entirely different way. There's a planet called WASP 76b, located 637 light-years from Earth, that astronomers have been calling hellish and terrifying. This world orbits so close to its star that the daytime temperatures reach over 2,400 degrees Celsius, hot enough to vaporize iron. But recently, astronomers discovered something so unexpected on this hellish world that they've had to add a new word to describe it: glorious. WASP 76b is what we call tidally locked, meaning one side always faces its star while the other side is in perpetual darkness. On the day side, the temperatures are so extreme that metals literally boil into vapor. The planet's fierce winds then carry this iron vapor to the cooler night side, where it condenses and falls as iron rain. Yes, you heard that right. It rains liquid metal on this world. But here's where it gets incredible. The European Space Agency's exoplanet hunting satellite called SEAPS has been observing WASP 76b for 3 years, and they've detected something astronomers never expected to see on such an extreme world: a glory effect. Glory is a rainbow-like phenomenon consisting of colourful, concentric rings of light. On Earth, you might see this effect when looking down at clouds from an airplane, where you see your shadow surrounded by rainbow rings. It's also been observed in the atmosphere of Venus. But detecting it on an exoplanet requires incredibly specific conditions. The atmospheric particles need to be almost perfectly spherical, completely uniform, and stable over long periods. The planet's star needs to shine directly at it while being observed from just the right angle. The fact that we can see this effect on the WASP 76b suggests something remarkable. Despite the chaos of iron rain and extreme temperatures, there are clouds made of perfectly round water droplets that have remained stable for at least 3 years. This discovery is revolutionary because it suggests that even the most extreme worlds in our galaxy might have stable atmospheric features we never imagined possible. It also opens up new possibilities for detecting similar phenomena on other distant worlds, potentially including the reflection of starlight off liquid lakes or oceans. The glory effect on WASP 76b might seem like just a lovely light show, but it represents something much more significant. It shows us that planets can surprise us in ways we never expected, maintaining order and beauty even in the most chaotic environments. As we continue to study these distant worlds with increasingly powerful telescopes, we're realizing that the universe is full of planets that challenge our understanding of what's possible. Whether it's potential microbial life producing gases in the oceans of K218b, or stable cloud formations creating rainbow effects on the hellish WASP 76b. These discoveries remind us that we're living in an era of unprecedented exploration. The next few years will be crucial as the James Webb Telescope continues its observations. Every new spectrum, every new atmospheric analysis brings us closer to answering the ultimate question: are we alone in the universe? The answer might be hiding in the atmospheres of worlds like K218b, waiting for us to develop the technology and wisdom to interpret their chemical signatures correctly. What do you think is more likely? A water world teeming with microscopic life, or an uninhabitable gas giant masquerading as a biological paradise? The truth is out there, floating in the cosmic ocean, waiting for us to discover it.